Hi guys, we're back to talk about the last installment of nutrient cycling. This time we're going to talk about phosphorus. So of course there's many other nutrients. We could talk about sulfur cycling and iron cycling and other things like that, but we're just going to kind of focus on these main four. So this is the last one that we're going to talk about in detail. So phosphorus has a chemical symbol of P. So you've probably seen that around. And it's a common important nutrient that's required by living organisms in the environment. So unlike the other compounds and elements that we've talked about so far, phosphorus is interesting because it really does not have a form where it exists in the atmosphere. So water and carbon and nitrogen all have forms where they exist in the atmosphere commonly, but that's not true of phosphorus. Instead, we typically find phosphorus in salts and rocks, or dissolved in the ocean. And then we also find it in organic forms like phosphates, soil, and plants. And so here's a little diagram, kind of a model showing the phosphorus cycle. So we have some different kinds of chemical transformations that occur in soils and sediments and living organisms, and then kind of the weathering of rocks and erosion of rocks to transform the phosphorus there as well. So we've kind of been focusing on anthropogenic or human-driven changes to pathways and reservoirs for these different nutrients as we've been going through. So in the case of phosphorus, the humans have been mining lots of phosphorus for the use in fertilizers. So we said there's about 2 times the amount of bioavailable nitrogen available on the surface of the planet today as there was about 100 years ago. And that's even more exaggerated with phosphorus. There's about 4 times more bioavailable phosphorus. And phosphorus is often a limiting nutrient in the environment. And so we talked about eutrophication in the last video clip about nitrogen, but this can commonly be associated with the increase in bioavailable phosphorus, in particular phosphate compounds, which are like PO4 or these organic forms or bioavailable forms of phosphorus. And so this is commonly mined from different kinds of rocks, and in particular, different kinds of islands that might have lots of guano, which is like poop, bat poop or bird poop, that have built up over long periods of time. And so a lot of times there's interest in mining those resources that have lots and lots and lots of phosphorus in them and then utilizing them in fertilizers. But unfortunately, it can lead to pretty serious degradation of natural environments in some of the places that this is happening. So here's a picture of Nauru, which is an island in Micronesia that's had a lot of negative impacts from this kind of heavy duty phosphate mining. So that's something to keep in mind. But if we go back to this previous slide, this PO4, and it has a negative charge, so it's a polyatomic, more than one atom, anion with a negative charge. And this is the common form that can be uptaken by plants. And so there's just transformation of phosphorus to that particular form from other kinds of forms in the environment. Okay, so we won't get into as much detail about that, but I think that's a good place to stop.